Well, that's a nice change for a start. I'm not used to starting my lessons with a round of applause. Thank you very much indeed. I do work for the NRICH project. I'm also a teacher part-time. So the first thing I wanted to say to you was that I'm really sorry. You're kind of here under false pretenses. It's not so much a talk, okay? You're not really an audience. And you have opted in by your very presence, whether you realised it or not. So now I have you captive in a room. I'm going to tell you what you're really here for. So I am less of a lecturer. In fact, I've never described myself as a lecturer. I'm a teacher. But in this case, I'm going to be more of a tour guide and a coach, like a sporting coach. So I want you to think of it like that. You're not really an audience, because an audience, you would sit and just take in information perhaps and have your own silent thoughts. That's not happening this morning. You are very definitely participants, okay? So I'm requiring you to participate in order to make this work. Okay, I can see a few nervous faces. I'm liking the smiles I've got in the room, okay? I will be coming back to you later. And the fact that you've opted in by your presence, okay, means I want you to think of yourselves as having turned up to a gym expecting to do some exercise. You don't go to the gym and then just, you know, pansy around at the periphery, kind of watching other people exercise. So in the same way today, I am expecting you to take an active part in what's going on. And because you are the largest class I have taught for quite some time, you're going to need to listen out, because although I am mic'd for the video, I'm not going to use the mic because I've never needed it in this room. But you will need to be aware that at points we will be pausing to kind of find out what other people think about things. So I would say, I hope that's okay with you. But if it isn't, then you're just going to have to sit still and smile and look like you're participating, because that's the plan for this morning. Okay. In thinking about this morning's talk, there is an educationalist called Brunner who did some work that talks about learning in general, not just in mathematics, but it is particularly pertinent to mathematics. And he talks about using the concrete when we first learn something. So we use actual stuff to help us understand it. You might think of Numicon or counting blocks or all sorts of other maths apparatus that you used in classrooms when you were younger. Moving on to a visual representation, okay? So maybe, you know, moving on from the concrete to being able to draw what you need, perhaps. And finally, moving on to the abstract or symbolic. Now, unfortunately, this is misrepresented. And people seem to think that you need to leave behind the previous phase when you get to the next one. A bit like a booster rocket disappearing from the shuttle that it's launched into outer space, okay? And lately, people have been taking on board far more that it is more of this archery model, that you learn you learn with the concrete apparatus first, and then you add a visual layer, and then you add an abstract or symbolic layer. But that at any point you might dip back into using concrete or visual as you feel the need to support your understanding. So we're going to be doing that this morning. We're going to be using concrete apparatus, which might be quite exciting for some of you who haven't used concrete apparatus for a while. We are also going to be using visual, and we are quite quickly going to ramp it up in the gym to get you on the scary machine that when you arrived through the doors you didn't think you wanted to have anything to do with, and into that abstract realm where we think about things just using what's in your head. Okay, so that's what we have in store this morning. I'm hoping I haven't done away with all of the smiles that started and now everybody looks petrified. Okay, so I'd like you to think then, this gym analogy is one I find really helpful when I'm talking to my students. I'm going to ask you to think about fitness and about actual physical fitness. We're going to talk about mathematical fitness related to it in a minute. So I want you to think, is it inherited? Are some people naturally fitter than others? And I mean in the physical sense, not in the fit sense. How does, oh good, I'm glad that went all right. I'm imagining people sitting there going, no idea what you're talking about, Fran. Okay, we're all on the same page, this is good. How does it develop and how is it maintained? Okay, so I'm going to give you 60 seconds to think in your own head and then have a conversation with somebody near you. Be mindful of the fact that you are sitting next to new people, okay, and that they may have interesting other ideas that would help you bounce off from today. Your 60 seconds starts now. yours. Oh, I tell you what, I clearly ought to teach classes of 90 on a regular basis because you're a lot more compliant than generally the classes of 25 or 30 that I teach. Thank you very much. I saw almost nobody sitting there doing nothing. I saw some people doing active listening. Active listening is where you sit there and you make interested and noises about whatever anybody's telling you, which to the casual observer therefore looks like you're totally involved in what they're doing. If you're thinking about what's for lunch, then you're hiding it well, I would have said. Okay, so is fitness inherited? You can answer, it's fine. Is fitness inherited? Do you inherit? No. So some people, could I just check? Could we have a show of hands? One person said no. Could you put your hand up if you agree with the person who said fitness is not inherited? We've got a smattering of people. Okay, all right, hands down. So the general, I would have said the majority opinion, but possibly only in a kind of referendum majority type way, so it's pretty closely matched, think that fitness is not inherited. So I don't inherit fitness from my parents. If my parents are physically fit, that has no bearing on when I was born, okay? Are some people naturally fitter than others? Anybody like to volunteer an opinion about that? Young lady on the end, you were nodding. Could you explain a bit about why you think some people are naturally fitter than others?
I don't know why, but they are.
Can you tell me in what way you think they are? So what were you imagining when I said some people are naturally fitter than others and you went, yeah, I have that experience? Lovely. So they might have a faster processing time, perhaps. Lovely start. Thank you very much. Anybody think about athletes? Anybody think about a particular example where you would say they are naturally fitter than somebody else? Can anybody think of an example? Yeah. Lovely. So it might be that Usain Bolt, okay, and his build mean he has it easier because he is, you know, more suited to the event which he has chosen to train for. It doesn't mean, okay, that I couldn't train for that event, but he might have a natural, i.e. genetic advantage because of the shape that he is. Lovely. Thank you very much indeed. How do you develop fitness? How do you develop fitness? Can I have somebody from this part of the audience? How do you develop fitness? Yes, please. Lovely. So it's actually down to how you take it. You can be as fit as you like. I said this to a group the other day, and a teacher right down the front went, okay, clearly of the opinion that it was not for him. But you can be as fit as you like. It just means it depends on what work you undertake. So you're only as fit as the exercise you have chosen to do. Okay, and how is it maintained? Well, perhaps we're partly answered by your thoughts, which is you can maintain it or you cannot maintain it and see the couch potato develop in all of us. Okay, so that's actual physical fitness. Mathematical fitness is the same then. So when you are developing your muscles in a physical way, how do you know you're developing them? When you go to the gym, or you play with a sports team, or you undertake an exercise class, how would you know? Can I have somebody in the back row? How would you know that I love it when people in the back row then go, oh, we're back row, she's talking about us, oh, help. Can somebody tell me how you would know your muscles were developing? They do get bigger, so it might be visual after a while. Is it visual immediately? No, much as we would like. I stepped over the gym threshold. Why do I not look immediately toned and fitter? So you're quite right, but that takes time. Immediately, on a machine in the gym or in an exercise class or on a hockey field, how do I know I am working and developing my muscles? Yeah. They hurt. Okay, and we learn to differentiate between, oh, okay, that's the burn. Can I do another press up? Yes, okay, I'll make an effort. And, oh, I've injured myself, I should stop. So that's something we learn. In maths, if we're talking about mathematical fitness, how do we know that we are developing our brains? How do we know you're growing your brain? You're creating new synapses, new neural pathways. What does that feel like? Yeah. You get a headache. So again, it might hurt. How do you feel when you are trying to do something that is not yet conquered by you? Frustrated, I heard. Thank you. What else? Yes. Confused. Lovely. What else? Frustrated, confused.
Like you're going around in circles.
Lovely. Like you're just, I'm not getting anywhere. I am repeating things. Wonderful. But do you feel stuck? Okay, I've got nods of, I'm amazed. If I'm in a lecture theatre with only 5 people who ever feel stuck, then clearly, you know, I'm preaching the converted, it should be the other way around. But we feel stuck, we feel frustrated, we feel confused, we feel annoyed, sometimes we get angry. So I'm just preempting you that because you've come to the gym with me this morning and we're going to develop your mathematical fitness, being stuck is great. Being stuck doesn't feel nice, but it means you are growing your brain. Okay? Not knowing what to do next is also okay. Okay? Seeking support from somebody else is fine too. Okay? Not letting them do it for you because you have to do your own thinking to grow your own brain, but certainly seeking opinions and seeing what that does for your understanding is expected and positively encouraged this morning. Okay, so without further ado then, I would like to share this piece of research with you. This was done by a lady called Sue Pope, and it came from an article called The Use of Origami in Teaching Geometry. Okay, and what happened was the task was given to a bunch of year 7s to communicate how to do a task to a bunch of year 6s, okay? All right, so I'm going to take it away. I'll put it back in a second, just while these people arrive. What you're going to do is, in front of you, you have some strips of paper. You have one each, and one each is not enough to complete the task that I am going to ask of you. So collaboration is going to be essential. I'm going to ask you to interpret, problem solve, and work out how to make the model that is going to be shown on the screen. And along the way, I am expecting you to be stuck, frustrated, need to seek help, and to coach each other. Okay? Interestingly enough, a coach is not somebody who does this. Dominic, can I just ask you to come and stand on stage? I didn't tell Dominic I was going to do this. He's now thinking, oh, help. You come and stand here for me. Okay, a coach does not do this. You turn up at the gym and they do not start moving your limbs. Could you pause for a second? Why not? Somebody who's just arrived, I'm going to put you on the spot. If you turned up at a gym and a coach did that, you'd be like, get off me. Why are they not doing you any favours? They're just doing it for you. So in the room, when we see coaching, I don't want to see just doing it for you, which equates to this. Oh, come here. It goes like, look, you see? And then giving it back, because you're doing what I've just done to Dominic. You're not allowing them to develop their mathematical fitness. What you could do, Dominic, could you back up a bit, and then could you copy me, okay, is you could show somebody else what to do. You don't have to flap your arms about. Thank you very much, Dominic. Okay, but there's coaching, and there's taking away the chance to develop their mathematical fitness. We see the difference? We've got people nodding. I wonder how long that... I know it's really hard to sit next to somebody who you've got the idea, they haven't. Not to go, give it here, I'll help you. But it really won't help them. Okay, so this is your challenge. You don't have enough with one strip. You're going to have to find a partner to work with. Off you go. Okay, pause. Do you know what? That's lovely. I heard people go, oh. Okay, if my students did that every time I stopped them working in a maths lesson, I'd think I was onto a good thing. I'd just share with you some things that are going on in the room in case you can't see it from my point of view, and in case you think that's a helpful coaching thing to have heard. There are people pointing, okay, indicating where it is they're talking about. There are people waving their hands about with, you know, kind of reference to a picture, but there's a lot of this going on. There's doing. There's some people who are just heads down, okay, I'm going to try this, and are only allowing themselves to look, I think, every so often. Trying things out is forming a big part of this, okay? Incidentally, the fact that none of you have been worried by the fact that I'm going to take your stars in and mark them is interesting. Because you know I'm not going to do that, I'm hoping perhaps you feel freer to have a go, and it doesn't really matter if you don't get it first time. Asking for equipment or paper is a crucial one. I told you there wasn't enough for you to do it by yourself, and most of you have ably found yourselves a partner who is equipped with a white if you have a green strip, or vice versa. Dan Mayer very sensibly said, who is a maths teacher from the States, what real-life problem presents you with the information you need and only the information you need in order to solve it. So part of becoming a mathematician is sifting, is deciding what you need and what you don't, okay? Is having the nous or the common sense to say, oh, I think 100 square would be useful here, or oh, actually, if I could build this with cubes, that would be clearer, or actually, could I have another strip like this because I don't think one is enough to do that. So I am firmly encouraging you to make those decisions for yourself. I used to have a banner in my classroom that said, be brave, use your initiative, even if no one's told you to. Okay, because students would say things like, you know, oh, could I do so-and-so? I was like, it's a brilliant idea, okay? And they'd say, oh, well, I'm not sure I should be doing things if you haven't told me to, miss. I was like, well, you're breathing all on your own, and I don't sanction that every second. So actually, take the decisions for yourself, okay? I'm going to give you 4 more minutes. On you go. I like the fact you're laughing. This is good. It's not the be-all and end-all. Keep trying. Ah. Say again?
That's number 3.
Yeah, that's a good point. Sadly, yeah, sometimes we don't have the complete information, do we? Unhelpfully, it is what's masked by that horizontal white bar.
I know.
Not useful, true. Now, if you've managed, can you lend any coaching expertise to the guys behind you? Okay? So you're not allowed to do it for them, but you are allowed to talk them into it. Last minute. Very impressed, ladies. There's a lot of... Okay, no, we'll try again. Now turn it over. Does it look the same? It should do. You don't know. You've got both sides, should look like that, so you're nearly there. And pause. Okay. Now, I told you I wasn't going to take your stars in and mark them. And fortunately, some people laughed. It's a different mindset if you know what you're doing doesn't have an assessment point. Generally, people feel freer to try. And I had told you that I wasn't going to, so hopefully you will have understood that the assessment criteria or the success criteria for this activity was not having a completed star. However, that said, there are some people who are feeling justifiably proud. If you are feeling smug that you've got a star and you want to risk people, you know, poking things in you at lunchtime, do hold it in the air. We've got one back here. Success, thank you very much. Anybody else made a successful star? One back here. I do like the slight, well, yes, but only if it's not going to get me lynched kind of a look. Could I ask you to check if you think your star is correct, that it is the same visibly on both sides? Because there is a partial success where your star looks like mine did on one side, but not the other. Okay, pause then and empty your hands, please. I know that's really hard for some of you. Okay, not just the Sheldons amongst the audience who have to have it all the way to the end of the Star-Spangled Banner. If you've watched Big Bang Theory, you'll know what I'm talking about, and if not, explain to those people who do later. Okay, so that was your first experience of, potentially, I'm guessing, trying something that you didn't know what the outcome was. And what I'd like you to think about for a moment is what skills did you need? What skills did you use? Because those two aren't necessarily the same. And what skills do you think you developed? And more importantly, while you're thinking about that, are there any mathematical parallels? Is there anything you were doing that you think is a totally valid, applicable skill to mathematics, okay? You have 1 minute to have those conversations, then I'm going to take some feedback. Go. Superb. Okay. Any skills that fall under those 3 categories that you think either, well, yeah, I needed that, I didn't have it, or, oh, yeah, I used that, or oh, I could really do with developing. I had a student walk in the other day, and because we're getting close to the end of term and I'm doing some paper folding with my classes, they said, one of them said, oh, we're doing paper folding, and the other one came in behind and said, oh, I'm not very good at paper folding. And I said, no, you weren't walking when you started that, and look how that turned out. You came in unaided all by yourself. And he kind of went, what? And I was like, well, you're only as good a walker as you are because you've been practicing walking. You just don't remember the bits where you fell over and looked an idiot and people, oh, never mind, and picked you up. Okay, the same is true of any skill. You'll get better at paper folding, like driving or cooking or swimming, if you do more of it. It's kind of uncomfortable because we don't like to practice things generally that we're not necessarily proficient at, but it is the way you improve. So, any skills that you think were needed, used, or developed? Somebody from over here, please. Okay, could you say a bit more about that?
Well, I mean, use it in maths as well. So trying out new things and then seeing what you have.
Lovely. Okay, so a bit of trial and improvement, definitely problem solving because you knew what you were aiming for at the end, but you didn't really know how to get there. Wonderful stuff. Thank you very much. Anybody in the middle? Please.
Seeing things from another person's perspective.
Lovely. Seeing things from another person's perspective, not just useful in mathematics, a useful social skill, okay? I have some students who find that very difficult, okay? They can only see things from their perspective, not because they find it unusual that not everybody sees it the way they do. So being empathetic, but actually physically seeing it from a different perspective. This poster was produced by Year 7s. Several of you were like, where's number 3? Okay, or they've cunningly left out, I've no idea what that step there is, so if the person designing the poster hadn't thought about the audience, perhaps you have got omissions and you have to see it from their point of view. Thank you kindly. Anybody this side, anything else to add? Teamwork. Okay, so we're learning to work collaboratively, okay? Give, take, trying things out, not going, give it here, which I saw at least one person go like this and then went, which was fantastic. I love the fact that you think Big Brother CCTV in here is going to zoom in on you and go, put it back, we saw you take that. Okay, all right, and anything else from up here, please, to add? Perseverance, lovely. So keeping going, not that, you know, oh, I can't do another push-up. Okay, but if I don't do another push-up, I'm not going to get the abs I want. Okay, if I just give up and throw all my toys on the floor, I am never going to make the star. It's all right not to make the star, but it's not all right to stop trying. Thank you very much. I would also offer accuracy, because if you are not accurate in this, if you just go, oh, well, there we go, you know, that's a fold, Fran, that'll do. You'll find that your model doesn't fit together nicely at the end. I'm an engineer by degree, okay, and we're very keen on accuracy, not least because the tolerances of things have to be micrometers now, okay, and therefore it's really important that you are accurate. Okay, so moving on then from that first exercise, we're going to do some exercises in imagining things, okay? I'll let you read this. Visualization relies on you being able to translate your knowledge of a 3D object into a visual picture in your head, which isn't strictly a 2D image, because the visual picture in your head allows, as a lot of computer modeling does now, you to rotate it and you kind of see behind it. In forming an image, it can be helpful to imagine moving around it, seeing it from another point of view, or tracing it with your hands. There was a lot of this. I saw a lot of people picking them up and kind of going to line it up with what was on the screen to see if that made sense with this. And lastly, geometric imagery, like we were saying with fitness, isn't something you're born with. It develops like any skill with practice. Okay? So I want you to bear those things in mind. What we are going to do then is some geometric imaginary workout. And it's going to involve this. You're going to solo try it on your own. You're then going to share with somebody near you how you found it, whether you managed it, anything you noticed while you were doing it. And then you're going to have another go, either together or solo on your own again. And then we're going to review. Okay, and we're going to, I was looking about not being a gym goer, you will be able to tell whether these are sets or reps, and I couldn't decide which they were, so I decided just to call them workout steps, because that seemed easier for all concerned. Okay, so, first one, okay, I'm going to leave this on the board to prompt you. You're going to try it on your own, Okay, and I'm expecting each one to take about a minute. So we're going to do some practice together. And it would be helpful if your hands were empty. I know that's difficult for some of you, but thank you very much for participating. Okay, first one. Picture your first name and read off the letters backwards. If you can't see the whole name at once, do it by groups of letters, and then try it for some other names of friends of yours, and make sure you do it by sight, not sound. I'll read just the first bit again. Picture your first name and read off the letters backwards. Some people find closing their eyes helps. You are very welcome to do whatever works for you. When you have, move on to step 2. Seconds. And pause. Next exercise. Very well done. And clearly some people do them faster than others. That's another nice mathematical parallel. There is research to show that being good at maths has nothing to do with speed. I'll say it again because it's not intuitive. Being good at maths does not mean being fast at arithmetic or anything else necessarily. Okay? When I'm working with younger students, I explain that I work at Cambridge University and we have some world-renowned mathematicians here, some more famous than others, and that none of them are fast. They take a long time to think about how they understand the world, what it means, and how they might use mathematics to understand it better. So it's not to do with being quick. Okay, second exercise then. Okay. Cut off each corner of a square as far as the midpoints of the edges. What shape is left over? And how would you reassemble the corners you've cut off to make another square? On your own to start with? I'll say it again. Cut off each corner of a square as far as the midpoints of the edges. What shape is left over? And how would you reassemble the corners you've cut off to make a square? If you're quicker this time, feel free to talk to your partner when you've done it. Okay, and pause. Slightly faster that one. We're going to do one more. Okay, one more. And those of you who think that being at the back means that I can't see you talking when it's meant to be your turn to do it on your own, don't be so sneaky. Okay, last one then. Take a 3x4 rectangular array of dots in one plane. Connect the dots vertically and horizontally. How many squares are enclosed? Take a 3x4 rectangular array of dots in a plane. Connect the dots vertically and horizontally. How many squares are enclosed? 30 seconds. Okay, if you've done, talk to your partner. Last 10 seconds. Okay, and pause. It's Absolutely fascinating watching. I almost wish there was a camera up here that then projected on the screen, but I guess you might get self-conscious about it. I can see, like, it's like you're doing, like on Mission Impossible, where he has those gloves to do that screen. It looks like that, but animatedly. And I've got people going, and then drawing it in front of them, and then assuming that the person next to them can see what they're drawing. So you're very focused. I'm impressed. Okay. Next activity then. So we've done some geometrical imagining. We're going to dip back into that center of the archery target and do some concrete in order to consolidate it. Okay? I'm going to show you a picture of a module. I am very keen on mathematical origami. I'm not so fussed about the birds and flowers bits, but I'm very keen on this sort of stuff. Okay? Works its way into my lessons a lot. I'm going to show you a module. That's just one piece. And then, after I've given you a minute to decide with your partner how you'd make that piece, I'm going to show you the model that can be made from those modules. So, first of all, the piece, a minute to discuss how you think it might be made, or to actually try making one if you would like with the paper that you've got in front of you. And then I will show you the model that can be made from those modules, and then your challenge is to recreate the model. Okay? All right, module first. 1 minute. Go. Okay. In order to help slightly, and because I had some very annoyed year 7s and 8s the other day tell me that that photograph wasn't helpful, and I was like, oh, I'm sorry about that. We did discard a lot of other ones that we thought were less helpful, but unless you've seen those, maybe it doesn't follow. This is the plan view of what you are aiming to finish with. If I just show you here, that in a slightly squished format is what you've seen the picture of, but in actual fact you'd like those fins, if that's what we're going to call them, to be perpendicular to one another so that it will then sit. And the person who folded this one, who wasn't me, was sufficiently accurate and tight in their folding that I was confident their model would then hold together well. Okay? All right. Again, I have not path smoothed for you. Okay? As teachers, we have a daily decision to make. Thank you, those people who are listening. A daily decision to make about how easy we make it for our students. If I make it too easy, when they come up against something difficult, they give up. If I make it a bit easy to get them involved, okay, it means they learn to encounter those problems and to solve them for themselves. So I have not given you enough on your own to make one of these models. Again, forcing collaboration, I'm hoping. Okay, please don't hit anybody else over the head for their paper. Okay, you've been very cooperative so far. All right, model, and then you've got 5 minutes to try and recreate the model. Okay, go. Oh, sorry, this one. That doesn't work so well. Okay, no. There we go. Same model from 2 perspectives. Could you pause and just look this way? If I genuinely were coaching you as a sports team, we'd be stopping and looking at a video of the last game we played and saying, look, what on earth are you doing here? You need to be here in order for our defence to work. If I'm coaching you for your mathematical fitness, I am showing you things like this, which is only incorrect because the folds are all back to front. And I am encouraging you, for accuracy, not to do folds on top of folds, but instead, when you take your piece of paper and fold it in half, like this, to make one coloured triangle, and then in the other direction to make a different coloured triangle, to then, when you fold it in half, what we call orthogonally, meaning vertical and horizontal, to make a white rectangle, and then a different white rectangle, so that when you pop the middle like a tent, the folds now naturally are going the right way to make your piece. Okay? I'm going to give you 2 more minutes before I'm going to pause you. Now, if we look down in plan view on this, like the one on the right, the square you can see around the outside is all the same colour. So this and this and this and this are green on that diagram. So when you look at it like that, you've got 2 that are pink, but I need another 2 pink ones over here somehow.
Okay.
So can you reverse your inside-outsideness of what goes in what to try and get me 2 pink ones here?
Yeah.
Does that help? Fantastic stuff. All right. That's more of a, got the pieces, not sure what to do with them. Can I give you a hint? How many pieces have you got? Okay. Guys, could I pause? We need some coaching from the floor. Can anybody in their noticing so far tell us how many modules we need? 4, 6, 3. Anybody got any feelings about any of those? Hands up for 3. Maybe connected with colour, thank you. Hands up for 4. Thank you. Hands up for 6. Ooh, if we're going with how the room feels, I'd go with 6. Can I also just demonstrate something that I've seen people doing that might help? You will notice on the right-hand diagram that the plan view has a green square. Guys, just for a sec, has a green square kind of around the outside. In order for that to be true, I'm going to need 2 modules of the same colour so that when I look down, whatever I've covered this bit with and this bit with, I see red. Okay? On you go, 2 more minutes.
The boys have done it.
Okay. Could you... I appreciate what I'm asking and promise you I really appreciate what I'm asking. Please could you empty your hands and look this way. Okay. Now, even with my having said you don't get a sticker if you make the model and you don't not get a sticker if you don't make the model, there are still some people in here who are fiercely competitive. So I feel your pain at having been asked to put down a partially constructed model that now you're like... However, our success criteria were different. Could you indicate, in the usual silent way, interestingly enough, I have a class who I swear to goodness, when I ask them to put their hands up, I think they activate some switch behind their ear that makes their mouths work as well, but you're much more mature. So, could you indicate in the usual silent way if you were stuck at some point? Fantastic, hands down. Could you indicate if somebody helped you or you helped somebody else? Marvellous, hands down. Hands up if you haven't given up yet. Not you haven't given up at all, just you haven't given up completely yet. That's a good proportion of perseverance in a room. If I had that in every classroom I was in, I would be extremely delighted. Okay, there are some things we've had people saying, do you know what, let's just take it apart and start again. That's a mathematical way of working. We've had some people say, hang on, we don't need to start again, we could just tweak what we've got. That's a mathematical way of working. And there are all sorts of parallels. Dara O'Brien wrote a fantastic article that was published in a teaching journal a couple of years ago where he said nobody is ever claiming that doing a star jump is going to get you a job when you go for an interview. However, doing star jumps gets you fit, and you certainly have to prove your fitness for some jobs at particular job interviews. And mathematics is like that. It's the star jumps for our brain. I am not suggesting that you will go into job interviews or even out into your wider life after today and feel a burning desire to do modular origami again. But I am saying the skills that you have developed here this morning will stand you in good stead when you are no longer needing to do modular origami. Just in the same way as if you went to the gym and developed particular groups of muscles, if you then ran a marathon or climbed a mountain, you've got the same built, toned muscles to use in another situation. And maths is very like that. So we're going to skip because I hoped we'd have more time, and you've done so brilliantly, we don't. I'm going to share with you the final really hard machine at the gym that you look at and think, man alive, is that just not an instrument of torture? That you might like to then go away and think about later. I am not expecting you to be able to solve it now. And I will make this available for teachers so that if you wanted it available at a later date, please feel free. What three-dimensional solid has circular profile viewed from above, a square profile viewed from the front, and a triangular profile viewed from the side? And do these three profiles determine the three-dimensional shape? That means, is there more than one answer? Now, because we are short on time, I will leave you cogitating over that and share with you a quote from William Morris, okay, who you may or may not know his design artwork, who said, "Have nothing in your house you do not know to be useful or believe to be beautiful." I went to Bristol recently to visit a friend of mine, and we went to an Open Studios exhibition, and in one of the studios there were dustbins in the corner full of old wooden rulers, and I spoke to the artist and she said, "Oh, I buy them from all over the place, eBay is great," and she chops them up into tesselatable pieces and then experiments with what forms she finds pleasing. So her visualization is very much in the concrete, but she has some ideas that she brings from the abstract. And she creates artwork like this. The one on the right is a magnification of the picture you see above the rulers in the central picture. And she sells them for a lot of money. And I had a conversation with the friend I was with saying, "Do you know what? I had no idea this she is an artist and I am definitely not. I didn't know this was art." And she said, "Well, kind of the point that what makes it art is that you'd thought of it, but you hadn't done it. So somebody else had had this idea." So this is my mathematics is beautiful and visualization is hugely important, compared to, at the other end of the spectrum, a gentleman called Robert Lang, who is well known in the US, who is very much, his field is origami in its various forms. And he says there are three fields, okay? Origami mathematics, which includes the mathematics that describes the underlying laws of origami. Computational origami, which comprises algorithms and theory devoted to the solution of origami problems by mathematical means, and the bit I've highlighted in blue, which is origami technology. Now, origami technology looks like this in one instance. This is a satellite that was designed to mimic origami folds because they needed some way of getting a small shape into outer space that could then open out and provide the solar power to run the satellite. So, I'm hoping that even if you're not burning to go away and make other models like these this morning, that you will have seen how beautiful geometry is and what the power of the imagination can do for mathematics. Thank you very much.